Okay, I received this question also. Let us see how we go about it. But please don't forget to subscribe the channel. Now, this one deals with the function and its derivative. The question is, what is the function? What is the derivative? So, the hint we have, you know that whenever I differentiate tan inverse of x, we get 1 over 1 plus x squared. I did the videos for these inverses. You can check through the playlist and you go to the appreciation, you will see all these. So always go to the playlists and then you search any topic or anything you want. But to come back to this, another tan inverse of 1 is 45, which is pi over 4, and tan inverse of a 0 is a 0. So now here, you start when I differentiate this, I get this. So it's a function and this derivative. What you do, you select, let your u be tan inverse of x. So when you differentiate u, we get 1 du. When you differentiate this, we get 1 over 1 plus x squared. But when you differentiate with respect to x, so this is what I'm talking about. When you differentiate this, we get that. So now you see the x over 1 plus tan, see the whole of this is going to be the x over 1 plus x squared, which is already there. The x over 1 plus x squared is equal to the u. Now because we have changed it from x to u, we also change the limits. You draw a simple table here for changing those limits. From now, x to u. We have said that our u is equal to tan inverse of x. So we are changing now from x to u. So when x is 0, the lower limit, when x is 0, tan inverse of 0 is going to be 0. When x is 1, here, then tan inverse of 1, we have seen is 45. But say 45 degrees is the same as pi over 4. Then we come back and substitute there. Now our integral will be, now integral from 0, the limit now in u, the limits in u are 0. Then for 1 in x, in u it's going to be pi over 4. Then tan inverse, you say it's u. Then the x over 1 plus x squared, the x over 1 plus x squared is the u. Then we integrate this, shall be having, when you integrate u, you get u squared over 2 from 0 to pi over 4. Now we just substitute in the upper limit and then the lower limit. So I have a half outside, this a half into now, put in pi over 4, the whole square, minus, put in a 0. When you put here 0, the whole square. So now it's that our integral is going to be a half into, when you square pi, you get pi squared over, when you square 4, you get 16. And you see when you multiply there, our integral becomes now pi squared 2 times 16, that's 2. Which means that now, but our I was there from there, integral from 0 to 1. Is equal to pi squared over 32 as we wanted to prove it. So, that's it members, you can send more. I wish you well.